Now we're going to look at simple magnifiers. These are magnifying glass, and after this we're going to look at things like a microscope that is a more complicated magnifier. So what does it mean to be a magnifier? Well, if I showed you these two pictures of car, which one's bigger? Well, if they're the same distance away, then certainly B is bigger. But if they're at different distances away, then you would say that if they're the same size, B is closer and A is farther away. So that's what we mean by simple magnifiers. A simple magnifier makes things look bigger, and they also tend to look closer. A simple magnifier consists of a single converging lens, so your eyeball is basically a simple magnifier. The device is used to increase the apparent size of the object. So if we look at what your eye sees, we're going to take an object that spans a certain theta and move it to B to cover more of your field of view. That would be a bigger object, and so that you would perceive as being bigger. So the simplest magnifier simply gets things closer. So the idea is that when we put objects at our near point, they are going to take up the maximum field of view that they're going to possibly take, because if we put them any nearer, we're not going to see them any closer, any better, because they won't be as clear. So the nearest we can view things is at our near point, and that is the point where they're going to take up the most view, and then most of our field of view. And then if it's really small, we still want to be able to see it. You can't get any closer because then you can't see it clearly because you're past your near point. What we're going to want to use is a magnifier. Put a magnifier between our eyes and our object to be able to make it take up more room and thus appear to be bigger because it's taking up a longer, bigger angle of our view. And so this gives us the idea of angular magnification. So the angular magnification is the angle with the lens divided by the angle without the lens. Remember that our other equation for magnification was h primed over h, so this looks very similar to that equation. So if you're using a simple magnifier, the equation is m theta is equal to 1 plus 25 centimeters over focal length. This assumes that the image is going to be placed at our near point, which is where that 25 centimeters comes into play. And then if we have something like a telescope, we're going to want to use 25 over f because this assumes the image is at the far point of the eye, and the far point is more desirable as the muscles are relaxed and you're going to have less eye strain when you're using that optical instrument. So where do these equations come from? Well, the angular magnification is, again, theta, really theta primed over theta naught. And if we looked at our original equation, we can get P and Q, substitute in where our near point is, and be able to get this equation. I'm not going to ask you to do these details, but here they are if you're interested. So magnification by a lens. When we have a single lens, it's possible to achieve a magnification up to about 4 times without the spherical aberrations that we're talking about. But we want to get more than 4 times. So with multiple lenses, we can get about a 20 times magnification. So these lenses can correct for those aberrations, as you can kind of see a variety of converging and diverging lenses in this lens system.